All right, so now we'll go in and create another source file, and this will be just our application file. So we'll call this one gcapp.cpp and click on Finish. And we'll get started writing our GC app. So in this particular file, we'll do a pound include, and we really only need to do one pound include here. We'll just do gcharacter.h, and that should be sufficient. And then we'll do our using namespace standard. And now we'll go about creating a main. So this is our application that's going to be making use of that gcharacter class. So the first thing that we'll do is maybe invoke the default constructor and see what happens there. So we'll do gcharacter, and we'll say gc1 is the name of this particular gcharacter object. And then we can go and insert stuff into that gcharacter object. So we'll do gc1.insert, and we can specify whatever tools we want to have. Maybe we have a potion in our tool array, and I'm going to just copy this line of code and paste it, and paste it a few more times, and come back and make some changes just to the string. So we don't want to have 5 potions, we'll just have a crossbow. We'll have say a candle. We'll have maybe a cloak. And the 5th thing that we'll have is a sword. Let's add one more. And we shouldn't be able to fit another one in there, so we'll just specify maybe Book of Spells. But this will not actually get added in because we only have 5 elements in our tool array by default. So let's go ahead and just test this out and see what happens. So let's do cout gc1 insertion operator endl, and let's see if things actually compile. So go ahead and build this. Looks like everything compiled okay. And let's see what happens when we run it. So whenever we run this, you can see that the very first statement that we have here, tool holder is full, cannot add any additional tools. That occurred from this line of code here because we were trying to add in another tool to our tool array, and when we weren't able to fit it in. So the next couple of lines was just related to whenever we did the cout operation. So we did cout gc1 endl, and that produced all of this business here. So we got game character John. So John was the default name since we didn't provide a default name here whenever we created our gcharacter object. Has the following tools. So it has, potion, crossbow, candle, cloak, and sword, just like what we specified here. And then you see another line of code down here. You see where our destructor was called. So destructor called for John at this memory location. So that's the location of that particular gcharacter object. And the reason why that got invoked is because as soon as we terminate main, then all the things that got allocated on the stack, which this thing here was allocated on the stack since we didn't use the keyword new, then it gets removed. And so the destructor is being called there implicitly whenever we terminate the main function. All right, so let's do something else. Let's create another gcharacter. So we'll create this gcharacter, gc2, and we'll specify that the gc2 is going to be using Bob, and we'll still use 5, I guess, for the size. The reason why I want to keep the sizes the same for our tool array, if you go back and look at the way that we coded up our overloaded assignment operator and also our copy constructor, they're only able to really have situations in which the source would have to have at least the same or less than the number of tools that the destination gcharacter object would have. Certainly we could change this up. We may come back and write in some code where we can have gcharacter objects that do in fact have different size tool arrays. Okay, so we've got this being created, gc2, and we can do gc2.insert, and we'll insert an axe in this particular case. So GC2 Bob has an X. And let's see, I think the next thing I want to do is actually create an example where we pass to a function a GCharacter object and also return a GCharacter object. So it turns out whenever we pass a GCharacter object to a function, we'll get an invocation of the copy constructor. And also whenever we return from a GCharacter object, whenever we return from a function, if we return a GCharacter object, then we'll get an invocation of the copy constructor. So I'm going to come up here before main and do GCharacter, and do the name of this function. I'm going to just call it example copy constructor. I don't know, it's kind of a dumb name, but I just want to show you what happens whenever we pass a GCharacter object in by value. So I'm going to have the identifier there for a GCharacter object called tempGC. And then in here, I'll just do a couple of cout operations, just so whenever we run this, we can see what's happened. So we'll say that the copy constructor is used twice, or maybe I'll say called twice. So it's getting called one time whenever we actually pass this thing in by value. And I'll do another cout here and actually specify that. So once for the formal parameter being passed by value. Okay, so we have that. And then we'll do another cout, and this will indicate the other time that the copy constructor is being called. So it's being called once for the return value, since we're returning the GCharacter object by value. Now notice in this particular function, we're not actually manipulating anything related to the GCharacter object, because we're basically just showing what happens whenever we pass and return GCharacter objects, that the copy constructor is actually being invoked. So we'll just return tempGC. Okay. It turns out that we'll also get an invocation of the destructor as well. All right, so we have that, and let's go and actually call that. So we'll do call to example copy constructor function. And we'll just pass in GC2 and do a semicolon there. And let's go ahead and run that and see what happens. And we'll save that and build it and run this. All right. We got a lot of stuff going on here. So we've got the same code that we saw before from our first few statements. And now you see that whenever we got to this particular line of code here, so whenever we did gc2.insert ax, we were okay with doing an insertion there, so we didn't have any problems since we have 5 elements. So that didn't output anything, but whenever we called the example copy constructor here, you can see that it said copy constructor called. So this line here, copy constructor called, was being invoked from our actual copy constructor. So if you remember, whenever we wrote our copy constructor, we had the cout here where it says copy constructor called. And now it's just outputting the stuff that we have inside of that function, so the stuff that we just wrote. And then the copy constructor gets invoked again whenever we do the return of the GCharacter object. And then you notice that we have several destructors being called. So you see the destructor is being called twice here whenever we had GC2. And so what's happening here is in this example copy constructor, we had 2 GCharacter objects being placed on the stack, the one that's being passed in and the one that's being returned. And so both of those get destroyed whenever we terminate this particular function here, xcopy, or example copy constructor. So those are those 2 lines of code there, or excuse me, those 2 lines being printed out. And the next 2 lines here relate to GC1 and GC2 being popped off of the stack whenever we terminate main. So whenever we terminate main, the destructors being called twice. And you can see that those do, in fact, have different address locations out in memory. All right, so let's do a couple more things. This is turning into a really long video. So this time we'll actually go in and make use of the copy constructor again. So let's do gcharacter, and we'll do GC3, assignment operator GC2. So this is a case where GC3 wasn't already in existence. Since it wasn't already in existence, we won't be invoking the overloaded assignment operator. We'll be invoking the copy constructor. So it's a very different story that we have here. If we wanted to see the overloaded assignment, so let me put a comment here and say that this is the copy constructor being invoked in this particular case. And we'll do an example where we do the overloaded assignment operator. So the way that we would do that is just maybe we'll take GC2 and use the assignment operator and use GC1. So both GC1 and GC2 were gcharacter objects that were already in existence, and so we'll get an invocation of the overloaded assignment operator. So if we want to, we'll save that and build it, and we'll run it, see what happens. So again, if we scroll back up here, you can still see all the code that we had before. The new stuff that's going on here is we see that the copy constructor is being called whenever we did this line of code here. The overloaded assignment operator is being called whenever we did this particular line, and then you can see the destructor being called for each one of those. Now you notice that we do have a couple of things that have the same name in terms of the attributes, which is perfectly okay, but they are three distinct objects out there in memory. So you can tell that they're three distinct objects, GC1, GC2, and GC3 by these values here. Okay. And I would assume that since these are placed on the stack, that they're being destructed or popped off of the stack, or whenever they're popped off the stack, the destructor is being called in the exact opposite order that we created them in. So it would be last in, first out. So the very last thing that we created was GC3. So this is no doubt GC3 here. This would be GC2, and this would be GC1 that's being destructed there. All right, so we have that. Let's see what else we can do. Okay, so the last thing that we'll do is just a couple of cout statements. So let's just do a cout, and we'll do GC2 colon, and we'll actually invoke the overloaded insertion operator. And we'll do the same line of code basically. So I'm going to just copy that, paste it, and change this up to being GC1. Just so we can see what happens here. And so I'm going to save that and build it and run it one more time. And we can see what happens. So we can see in this particular case here, whenever we did the cout operation, we got GC2, which is John and John. And you can see that they have the exact same values there for their tool array. If we wanted to, I guess we could also do Bob. So that was GC3. So we'll do one more here where we do GC3 and save that, build it, and run it one more time. Okay, so now we can see Bob being printed out. And yeah, so this is GC3. So you can see that GC3 is in fact being popped off the stack first because that's Bob. GC3 is the only one that has the name Bob, whereas GC1 and GC2 have the name John, since they made use of the default constructor. All right, so that is pretty much it in terms of this particular video. I'll probably put the actual code maybe with some additional notes up somewhere and put that in the description in terms of where you can find the code and download it and look at the more detailed comments that I have. All right, so that's it. So hopefully you know a bit more about the rule of three and when you have to use the rule of three, the syntax for writing a copy constructor, overloaded assignment, and a destructor. Again, with the copy constructor, that's going to be invoked any time in which we may do something like this, where we're assigning one particular object to another object, and we have a class in which the copy constructor is written, and this particular object doesn't already exist, so we would have the copy constructor being invoked. The other two times that we would have the copy constructor being invoked is whenever we're passing a particular object by value or returning an object by value from a particular function. In terms of the overloaded assignment operator, we would have that being invoked if we had some particular objects already in existence, such as GC2 and GC1 in this case, and we're just wanting to take all the things here that we have in GC1 and assign it to GC2, but we've done a deep copy here as opposed to a shallow copy. Same thing here, a copy constructor also does a deep copy. The destructor, once again, is just taking care of those things that we allocated out there on the heap dynamically using the keyword new, such as our tool array. All right, so that's it, and hopefully you enjoyed this video.